Okay. All right. So chain rule. So we were continuing on chain rule. We did, like I said, we did one problem on Friday, and then the rest of the time you guys worked on your just the regular assignment. Okay. So what happened? Okay. Okay, so let's take a look at this one. Let's take a look at letter C after the one we just did B. Okay. So if we're doing any kind of chain rule problem, or really any kind of derivative problem, right? We know it's derivative because it says find dy dx. That means find the derivative. Okay. So anytime we're doing a derivative problem, before we actually find the derivative, what are the things that we should do? What's one thing that we need to do? Yeah, change it to powers, right? Change it so it's a powers problem and not a root problem, because you can find the derivative of a root, but it's a lot easier to find it if it's a power, right? Okay, so let's do that. So it's going to be y equals -4 is the coefficient times. Now I see I have this root, so everything on the inside is going to be to the 1/2 power. Oops. Okay. No more roots. I think that was the only root. Now I have a power. Okay, so okay. All right, so the outside, we start with the outside first, right? The outside is the entire thing, but when we want to take the root, or sorry, when we want to take the derivative of it, that's right here. Everything right here is a part of the outside. Everything that I didn't highlight stays the same the first time around, right? So I have 4 times something to a power. So the derivative is move the 1/2 to the front. When I move the 1/2 to the front, you're going to get -2 times, and then the inside stays the same. To the -1/2 power, right? Because I subtract 1 power. Okay. Then from the original, where that's yellow, I move inside 1 power, or inside 1 function. That'll be this guy here. Okay, and not the 4x cubed yet. That's last. Okay, so once I get that, what is the derivative of sine? Cosine. Yep, cosine. Okay. And then the last thing, now I can go to the inside. Now I can go to the most inside function, which is 4x cubed, which will be 12x squared. Okay. The last thing is take away the negatives. If there's any negative exponents, go fix those so that they're not negative anymore. Anything I can combine. So I see right here, I have a -2. That's a coefficient for this guy here. I can't distribute because of this power here. The only coefficient here is a 1, but here's a coefficient as well here. So what I'm going to do is I'm going to multiply this guy and this guy to make -24. Okay, x squared. So I'm gonna cross them out. They don't go away. I'm just gonna cross them out because now I'm done with them. Okay. So it's not like they're not going away. They're not canceling out. I'm just done with them for right now. So I probably shouldn't cross them out like that. I probably should highlight them. Okay. I have cosine here, which doesn't have any powers on the outside or anything. So that's just going to be cosine is going to go up here. Cosine 4x cubed. Okay, so that guy's gone as well. The only thing left has the negative exponent. This guy right here has a negative 1/2. This whole thing here. So that means it's going to go back underneath. And it'll have a root. Okay. All right. Okay. All right, so try letter D. I want you to give letter D a shot. Give letter D a shot. Okay. All right, so I'll get started. If you guys still working, keep working, but I'm gonna get started on this. So I underline equation, tangent line is derivative. Okay, so first thing we need to do is find the derivative. Okay, so 3 is a coefficient in the front. That's not gonna, it's just gonna be 3 times whatever I get. So 3 times secant, that's the first layer. Okay, so I got to find the derivative of that. So 3 times, what's the derivative of secant? Yep, repeats itself times tangent x. It repeats itself, so whatever was on the inside times tangent whatever was on the inside. Okay. All right, and then the other layer is the inside. The derivative of 2x is just 2. Okay. So 2x and 2x are angles. We can't combine them, we leave them. But we do have 3 and 2 out here, which we can multiply together to make 6. So I have 6 times secant 2x, tangent 2x. You can put a multiplication sign in the middle if you want, just to remind yourself that it's multiplication, or you don't have to. It's implied it's multiplication, but just for your own benefit, sometimes it's helpful to do that. Okay, that's the derivative. Okay, so that is the derivative of 3 times secant of 2x. Okay. Now, what do I have to do? What do I do to come up with the equation? What do I need to do next? Anywhere I see an x, I need to put pi over 8 in. Okay, so I go f prime of pi over 8 equals 6 times secant 2 times pi over 8 times tangent 2 times pi over 8. Okay. Simplify the angles because it's 2 times pi over 8. So 6 times secant 2 times pi over 8 is 2 pi over 8, which reduces to pi over 4. Same over here. Because 2/8 reduces to 1/4. You can put 1 pi over 4, but you don't need it. Okay. Then I'm going to need to go figure out what secant of pi over 4 is and what tangent of pi over 4 is. Okay, so this is a great time to do this. If you see this on the quiz or on a test, you can't use your sheet, right? You're not allowed to use this sheet here, right? You can't use it. You can use it now since we're not doing a test or a quiz. So I'm going to show you how I would do it, how I would do it if this is where a test or a quiz. Okay, if you have your own system, you'd use your own system, but this is how I would figure out what those values are. Okay, so the first thing is those reflect, or those come from the unit circle. Okay, they come from the unit circle. So there's 4 quadrants to the unit circle. Okay. Pi over 4 is the same thing as 45 degrees. 45 degrees is right there. That's 45 degrees right here. So that reflects this triangle here. So this is 45 degrees. That's the angle there. Okay, it's a right triangle. Both of them are pi over 4. So the coordinates there are the same. Square root of 2 over 2, square root of 2 over 2. Okay, you should know all of the coordinates because there's really only 3 different coordinates for the whole unit circle. There's square root of 2 over 2, positive and negative. There's square root of 3 over 2, positive and negative. And there's 1/2, positive and negative. Those are the only ones. So if you memorize those, it don't matter where on the unit circle, those are the only coordinates you're going to have. Okay, so those I would memorize. All right, if you haven't already. And then this guy here, the hypotenuse is always going to be 1. Well, since they're both square root of 2 over 2, that means this is going to be root 2 over 2, and that is going to be root 2 over 2. Okay, so we got secant first. Secant of pi over 4. Okay. Well, secant of anything. Let's talk about secant of any angle. Secant is the reciprocal of what? Cosine. And cosine is x over 1, right? Or just x. So the reciprocal of that is going to be 1 over x. Okay. So the x coordinate for pi over 4 is square root of 2 over 2. So it's going to be 1 over square root of 2 over 2. Okay. Now, you can't leave it like that because there's a root on the bottom. So you're going to have to rationalize it a little bit. So by rationalizing, I mean multiplying by, so we have square root of 2 over 2. Rationalizing means multiplying by whatever is causing the issue. So if you multiply by the square root of 2 over 2, on the bottom, so the top you're going to get square root of 2 over 2. On bottom, you're going to get 2 over 4. All right? Because square root of 2 over 2, square root of 2 times the square root of 2 is positive 2. And then 2 times 2 is 4. Okay, so you have a division problem now. You're going to keep, change, flip, keep the first one times the reciprocal of the second one. These guys will simplify. That'll be 2. That'll be a 1. So you get 2 times the square root of 2 over 2. But you can still simplify that because this guy and this guy divide into 1. So now you get the square root of 2. Okay, so you go back up here. This guy right here is equal to the square root of 2. Okay, and then we got to do the same thing for tangent. Tangent has the same exact coordinates, right? Tangent has, because it's 45 degrees. We didn't go anywhere, it's still 45. And okay, so what is the, if I want to find tangent of an angle on the unit circle, what is it? It's y over x, right? Y over x. Okay. Well, y is the square root of 2 over 2. X is the square root of 2 over 2. So when I divide those, what does it make? 1, yeah. Anything divided by itself is always going to be 1, positive 1. Okay. So when I multiply all those straight across, I get 6 times the square root of 2. What does that represent? Slope at pi over 8. Slope at pi over 8. Okay, so up here, I'm going to write my equation down. So I get y minus something equals slope, which is 6 times the square root of 2 over 2, or square root of 2, minus x times something. So once I get my x and my y, I'm done. One of those I already have. Which one do I already have? I already have x, right? It's right here. Pi over 8. how do I come up with my y? What do I need to do to come up with my y? Go for it. To the original equation, right? Pi over 8, plug it into the original. Okay, so let me do that over here. So not f prime of pi over 8, f of pi over 8. So you get 3 times the secant of 2. That looks familiar. Secant of 2 times pi over 8. I think I just did that. So I know this answer, which is the secant of pi over 4, right? We just did that. We did that right here. Oops, not that, right here. And we found that the square root of 2 is the answer. So we got 3 times the square root of 2 y minus. There we go. Okay. Right. So out of the 3 questions, at least one of them will be a trig question on the quiz. At least one of them. Maybe 2, not all 3, but at least one of them is going to be a trig question because you see it a lot. Now, the ones that come up a lot are tangent, or sorry, the 3 main ones, sine, cosine, tangent. Those are the ones that come up quite a bit. And then the reciprocals that come up quite a bit are secant. Secant is usually the big one that comes up quite a bit. Okay. So those are the ones I would focus my attention on if you're trying to memorize those for the quiz. Okay. Flashcards are a big help. They help a lot on this. They'll stick in your memory for those. I would suggest that if you're having issues with memorization of those guys. Okay, because we've been using them, but not too much. By next chapter, they'll kind of stick in your head by then. But up until then, okay. Okay, so for each of the following, use the fact that g of 5 equals -3, g prime of 5 equals positive 6, h of 5 equals 3, h prime of 5 equals -2. Okay, to find f prime of 5. Okay, if possible. If it is not possible, state what additional information you would need to find the answer. So for all of these, I got to find f prime of 5. That's my goal. Find f prime of 5. So for A, B, and C, and D. Find f prime of 5. That's my goal for every single one. Okay. We've done problems like this before. Last week? No, 2 weeks ago? I think we did problems like this before, but they looked a little differently. What did they look like when we did them back then? What did they have? Tables. Yeah, they had tables, right? There was even a problem we did that didn't have a table. And I said the first time they give you a bunch of information like this, the first thing you always want to do is make a table. Because if you make a table, it's a little easier to find your information. Okay. So let's make a table. We got G and H. G and H. And also their so we got G, we got G prime, we got H, we got H prime. Okay, and then I have some answers for those. I have G of 5. And that's it, right? Just 5. I have G of 5, G prime of 5, H of 5, and H prime of 5. Okay, so G of 5 is -3. G prime of 5 is 6. H prime of 5 is 3. H prime of 5 is -2. Okay. All right, so now first thing I got to do is find the derivative of 5. The derivative of f first, and then I can plug in 5. So this one we've actually done before. We've actually done before. What am I going to do? Product rule. There you go. Yeah, isn't it? It's G times H, multiplying together, right? So first one stays the same times the second prime or derivative plus the opposite. Plug in 5 now. Go to my table. G of 5 is -3 times H prime of 5 is -2. G prime is 6 times 3. So it's 6 plus 18, which is 24. Okay. We've done that before. You've had an assignment actually on it. That's not new. The next one is new though. The next one is new. What are we going to do for letter B? What's going to be our step? Are we going to use product rule? Are we going to use quotient rule? Are we going to use sum and difference rule? Are we going to use a different rule? Power rule? Which rule are we going to use for letter B? Doesn't it look like just like this, except G is here and H is here, right? It looks like that, right? Well, what did we use? Chain rule. Okay, we're going to use the same thing for here. Okay. G, H is inside of G. So G is the outside function. H is the inside function. Okay. So if we're finding derivative, we're going to go G prime. Everything else stays the same. Inside H prime. Done. Okay. So now I'm going to plug in 5 because that's what I got to figure out. Okay. So the first thing I'm going to do, well, over here, I can do this guy here, H prime of 5, go to my table. If I go to my table, H prime of 5 is -2. This guy over here, though, it still has an outside and an inside. So I can't do anything with the outside yet. I have to solve the inside. Just like in math, you always simplify inside the parentheses and then you work your way out. This guy here, I can figure out. So I go to the table. and I find out what h of 5 is. H of 5 is 3. So that's 3. Well, guess what? I still have the G prime. I simplified h of 5, but I didn't simplify that G prime. Right? So now what I need to do is I need to simplify this guy here, G prime of 3. So I go to my table, and I don't have it. I don't have G prime of 3. I only have G prime of 5. Okay, so let's go back to the question. What did the question say? If it is not possible, state what additional information you need to complete to find the value, needed to complete the value. Well, the only thing I need is this guy here. This is the one I need. So I say need G prime of 3 to find the value, to find F prime of 5. If I had G prime of 3, I could do it, but I don't. So I can't finish it. Okay, so next one is C. I want you to do letters C and D. Try letters C and D, the last two, very last two. Give you about 5-10 minutes to do that. Just give that a shot, and then we'll talk about it. If you get it wrong, big deal. It's not a quiz or a test day. The only way to get better is by trying it on your own. Okay. So don't wait for me to do it, because then you're not trying it on your own. Okay, so for letter C, I got 4/3. Take a look at my work. If you got the right answer, great. Go on to D if you're not already there. But if you didn't, I'll put the work, I'll leave the work there. So all right, so the last one. The last one is a chain rule problem because it's something to the third power. Well, actually, that's just the power rule, right? Something to the third power, right? But if that something is more than X or 4X, or if it's got more to it, then we have to use quotient rule, or sorry, we have to use chain rule. Okay, so that's what we're going to do there. Okay, so first thing is the outside. The outside is something to the third power. Okay, so if we're going to find f prime of that, we move the 3 to the front. Everything else stays the same on the inside, and the power moves to squared. Okay, that's the first outside. That's the outside layer. The inside layer is right here. G of x. So g of x, the derivative of g of x is just g prime of x. And that's the 2 layers. Okay. So now we have to find f prime of 5. So we have 3 times g of 5 squared times g prime of 5. I just substituted 5 for x. Everywhere I saw an x, I put in a 5. Okay, so I got to go to the table and find g of 5 and g prime of 5. So the table, g of 5 is -3. So 3 times -3, squared times g prime of 5. G prime of 5 is 6. Okay. So that goes in here as 6. Okay. So I have this left. I have multiplication and exponents, right? 3 times -3 squared times 6. Okay. So I go exponents first. So 3 times 9 times 6. Then I just have multiplication, 27 times 6 or 54 times 3, which is 100 and, see, 27 times 6, 116, 162. Did I do that right? Okay. All right. Sorry, I at least want to do a chain rule quiz, just because to get another quiz in there, right? As much as we hate taking tests and quizzes, the only way for your grade to go up is by taking more tests and quizzes. Okay, I hate to say it, but that's the way to do it. So the only people who should say, I don't want to take a test or a quiz, are the people who are perfectly happy with their grade and they don't want to rock the boat. If you want your grade to go up, this is the only way to do it. So I try to give you as many opportunities as possible. Okay, especially quizzes. Tests we can only take every chapter, right? There's only one test every chapter. But quizzes we can take as many as possible so that it'll help, boost your grade up. Okay. Alrighty. Anything else than that? Just make sure you've completed or make sure you finish by today the assignment from Friday. Okay. We started in class on Friday, but if you weren't here on Friday, it's there. Make sure you scan and upload. Yeah. That's it. Yeah. So I think Delta Math on Delta Math, it's accepting those answers. And if it says it, do it. Okay. That's why I have you guys do it on paper too. I give you like the paper. So on paper, change it so I can back it up with it. So I can have that backup. So if you have a negative exponent on Delta Math, it's okay. But I always go to the paper. So make sure on paper you change it so that it doesn't have a negative exponent. Yeah. Mm-hmm. No, it's not wrong. No, not at all. Not at all. It's not wrong. Like if I finish my answer and I get like 2/4, right? That's my answer. I'm done. And the answer is 1/2, right? That's technically not wrong, right? Technically, it's not wrong. It's the same thing. 2/4 is 1/2. If I divide them, I get 0.5, right? But one is a better answer than the other. It's that same way. So it's technically not wrong. It's not wrong at all. Delta math doesn't have a lot of multiple choice. And on multiple choice tests, you won't see any negative exponents. Okay, yeah. But no, it's technically, like I said, it's not wrong. On paper though, when you're doing it on paper, you should always leave it without a negative exponent. So change it back, put the roots back in, move it around, you know, you got to move it to the bottom or move it up to get rid of the negative. You should always do that. But yeah, it's not wrong. It's not technically wrong. Okay. All